Okay, I was expecting 6 people, so that's pretty great that you actually decided to come since the school is over and the weather is pretty nice outside. So I'm not sure if you want to stay or maybe, the weather. Anyway, so, okay. Hi, I'm Tomek, and I've been practicing DevOps for many, many years. If you've watched any of my videos on YouTube, you probably know that I love particularly one technology, which is Kubernetes. And is it really that good? I've been showing it, I've been teaching about Kubernetes for many, many years, and I've used it in many projects as well. But is it really that good? So can it make a good coffee or a decent cheesecake? Unfortunately not, and I'm really disappointed about the latter feature that is lacking. It should be essential. Anyway, so today I want to talk about how to harness multi-cluster Kubernetes environments in production. So I'll be talking about tools. It's not going to be a deep dive session. It's rather about practices, about some problems and solutions. So let me go straight. Let me just go to our agenda. So all the things that I will present today are based on my experience. So I worked at DevSkiller, which is an excellent startup. I no longer work there, but I miss the team. They are great developers, great people, and I'll be talking about my experience, about what I've learned, what we've built, and so on. So DevSkiller is a startup, as I mentioned, and I will refer as we because I feel as a part of the team still. We have 2 products, which are software as a service products, one of which is Talent Score and Talent Boost. And I'll be talking about one of the problems that we've encountered. I'll be talking also about practices around building many container images, and also how to, of course, harness multi-cluster environments. And if you decide to stay, I have a quite interesting surprise at the end, so stick with me, and I hope you won't be disappointed. So I remember it was a couple of years ago, I guess more than 3 years ago now, when I was invited to an internal workshop at DevSkiller. I was invited by its CEO, which is Kuba Kubriński. Maybe you know, he's a famous Java architect. So I was invited to share my experience, to face their doubts regarding Kubernetes, because they were considering Kubernetes as their platform. So they wanted to move from their virtual machines to Kubernetes. And I was like, okay, come on, with Kubernetes, of course you should do it. The workshop went pretty well, and after a few months, they finally migrated their workloads to Kubernetes. But after a few months, I got a call from Kuba, and Kuba asked me, Tomek, we have some problems with our applications. Suddenly, from time to time, we have some outages, and we don't know why. And I was like, come on, it's Kubernetes. It doesn't work that way, You must have done something wrong. You must have misconfigured it, and so on. I gave him some tips regarding some configuration and so on. However, it didn't help. And after a few months more, I was invited to join DevSkiller, and indeed, I had an opportunity to face the problem and to try to solve it. So, what was the problem? So let me just introduce some of the findings that were results of my research. So, I'm not a fanboy of any particular technology, although some people may find me as a Kubernetes fanboy. No, I'm not. Kubernetes is an awesome technology. But at DevSkiller, we have Kuba. He's a great Java champion. And when it comes to champion, we have also our CTO, Tomek Nurkiewicz. He's a really amazing guy when it comes to Java. So we have everything when it comes to our backend services written in Java. Well, what can go wrong with technology from 90s that is used with technology from 2021, 2022? Well, when it comes to Java, there is one interesting issue when they run from Kubernetes. They require a lot of CPU at startup. So what we found out is that when many applications start, they just fighting for CPU resources. So it's a kind of thundering herd problem. So it often happens when when multiple apps start at the same time on particular nodes of the cluster. So this was actually our main problem. So from time to time, our nodes, for some reason, they experience a lot of Java apps starting and starting initialization, and yeah, so that was our problem. So we went with our investigation even further. And what we found out is that our cluster, well, the nodes of the cluster had very short uptime. Indeed, application had finally started, but with multiple restarts. So we decided to recreate the problem. We used our stage cluster, our dedicated stage cluster. And what we found out is also very interesting. So it turned out it was caused by upgrades. So on our clusters, we use GKE, so we use Kubernetes as a service on Google Cloud, and we have clusters with auto upgrade feature enabled, which means that from time to time we have some upgrades that were initiated by Google, that is responsible for our Kubernetes clusters. So how it works? So when Google decides that it needs to upgrade a cluster, of course, within the time set by us, with some maintenance windows. So when it starts the update process, a new node appears. Let's assume that we have very small cluster that is composed of 3 nodes, and a new node appears. And after some time, one of the old nodes gets destroyed, and then another new node appears, another old node gets destroyed, and so on, until we reach the very, very crucial point where there is no app available. So all these apps on new nodes are just starting, are in the middle of initialization. So they are fighting for CPU resources, and so this is our outage, because we have no apps available. So we try to come up with some solutions to that problem. So we first try to tune our CPU resources. Of course, the more CPU resources you provide to your applications, to your Java apps running in containers, the faster they will start. Of course, at the same time, the more CPU will be wasted, because the high demand for CPU is only during the startup, not after the startup. According to our metrics, it's only required there. So we did that. It helped a bit, but it didn't solve our problem. Then we were considering using a vertical pod autoscaler. It's an interesting object in Kubernetes, and it should help us, because its role, its main task is to adjust CPU requests and limits. However, it sucks for this case, especially because when it does indeed increases or decreases CPU resources, it needs to create a new pod, which is just useless for us, because the main point is to the main problem for us is, is when a pod starts. So it just sucks for our case. Maybe it's for some batch jobs or something like that. So it didn't help. We were also considering writing our own custom operator. Actually, I came up with a name. It was supposed to be a balloon operator. It would work like a balloon by artificially increasing CPU requests so that only a small number of apps would start on a particular node, so no thundering problem would occur. But we probably would have written the operator if we hadn't found our final solution. However, before I reveal the solution, we also found some misconfiguration of our probes. And let me just tell you something more about it. So you probably know that if a container starts, you can assign, you can configure some probes. You can attach some probes to it. So, for example, we had our probes attached to every container with our apps, and we had initial delay seconds parameter configured, which adds artificial delay for livenessProbe, and this is the probe that was very problematic for us. So, of course, when 3 consecutive fails occur, the container gets restarted. And that was our problem, because of course, our initial delay seconds assume that our apps start in around 2 minutes. But when they fight for CPU resources, they don't start in 2 minutes. They often start in like 7, 10, or even 15 minutes, because they fight so hard for these CPU resources. So we had to reconfigure it, and we actually did, but it didn't help. So application still got stuck in this, still was unavailable. So we also learned something very important, because I'm not sure if you know, but there are 3 types of probes available in Kubernetes. So from version 1.20, there is a third probe called startup probe. And it would probably be very beneficial for us if we had Kubernetes 1.20, but we didn't. So how it would work with Kubernetes 1.20? With newer Kubernetes versions, you can configure this additional startup probe, which just delays, which actually pauses all the readiness and liveness probe until it succeeds. So you set up a very long time for the startup node to check for your availability of your app. And then when startup probe is ready, then you configure your readiness and liveness probe. However, even if we had startup probe, it wouldn't solve our problem. And but during the investigation, we had this eureka moment, and it was so gratifying and embarrassing at the same time that I need to just delay the reveal of the solution. So stick with me, and now I will move on to some other topics. So when I joined DevSkiller, I was actually shocked to find out that the whole environment, the whole platform, including application deployment, cloud infrastructure, so the things that I was supposed to be responsible for, are so automated, are maintained by so few people. And I told Kuba, you must be joking. No, it's true, it's true. We did it by ourselves. I mean, come on, it's all automated, and probably you are hiding some infrastructure developers that you don't want to show. No, it's true. And actually, it is true, it was true. So what are the magic ingredients? Besides really hard work, which I found out, and perseverance, it's all about standards and conventions rather than testing multiple solutions, sticking to standards and conventions. So how we used it at DevSkiller, what kind of tools did we use, and were there any challenges? Let's find out. First of all, we have a couple of types of clusters. The first type of clusters is application. So we have two application clusters, one stage and production. So they all run in the same region, somewhere in Western Europe. They have the same configuration. So the only major difference between those clusters are the nodes that are used inside these clusters. Because we don't want to overspend money, I wouldn't call DevSkiller or myself or Kuba as cheap. However, we don't want to overspend, and that's why we used preemptible nodes. Which is a pretty nice solution if you want to save money, and at the same time, you get something for free. You get a chaos engineering solution for free, because these nodes get destroyed every 24 hours, and sometimes they got destroyed almost simultaneously, which caused some outages on our stage environment. So we use stage environment a lot, like for all of the testing and all of the end-to-end tests and performance and so on. We also use update channels, which is a funny thing, because they actually, by using this auto-upgrade feature, we caused the outages, because we have auto-upgrade feature turned on, and that was causing our outages. However, what we found out is that GKE is awesome, because you can use multiple channel, and our stage cluster gets updates earlier than of course production cluster, which gives us some time to prepare for some major API changes and so on. It works pretty well for us. And so this was our first set of clusters, but this is a map, and this map shows the locations from which our candidates, because we provide platform for evaluating developers, their skills. So this is a map, and as you can see, we have plenty of places from which our candidates connect to our platform. As you can see, even there are some islands on the Pacific Ocean, and sorry, on Atlantic, Pacific probably as well, on the Atlantic Ocean. And I was curious, how did they manage to get some fast internet without some delays? Because this was our concern, because we wanted to provide a really awesome feature for our candidates. We wanted to provide them with their own IDE that was running in the web using, of course, Kubernetes and containers. So we measured latencies and locations for our I would say, customers, our candidates, and we decided that we decided that we would create 5 clusters in 5 distinct regions. And yeah, so these 5 clusters were dedicated for this new feature. And of course, we wanted to provide to our candidates direct access to containers running inside pods on these 5 clusters, or actually on one of the 5 clusters. But we encountered really, really big problem. Well, on our platform, we have thousands and thousands of tasks and thousands of candidates join or actually connect to our platforms on a daily basis. And how our exams, how do they work? So if a recruiter selects a task, then we create a specific instance of a task, which we called exam. And in our new project, we wanted to create also additional thing, which would be a container with all the things that are required for our candidates to finish successfully, hopefully successfully, the exam. So, but we didn't actually know a few things which turned out to be crucial. So we didn't know when will candidate join or start the exam, and where they will connect from, which location, from some island on the Pacific, on the Atlantic Ocean, or maybe from Poland, I don't know. So how to make it as smooth as possible using Kubernetes. So we wanted to create a seamless, a very fast solution for our candidates. So we wanted to create a container image per candidate. So our first approach assumes that, well, it worked. Actually, it not assumes. We have manager, so it's a piece of software, our piece of software that creates a deployment. And this deployment creates well, PVC object is also created at the same time, and PVC object orders a persistent volume on our GKE cluster, and also deployment creates a pod. And during the first phase, we warm up the task, so this pod actually runs for a couple of minutes, like 20 minutes. during which it downloads all the artifacts that are required for this particular exam or with a task. So during the warming up phase, the data is written into this persistent volume, and after it finishes, the pod gets destroyed because we scale down the deployment to 0, and then we wait for our candidate to join the exam. And during the phase 3, we just launch once again our deployment. We actually scale it up to 1, and then our candidates can connect to its exam. However, this was already shown. However, one of the biggest problems was the fact that it was quite, if not very, expensive. Why? Because we didn't know which location our candidate would join. We had to do it on all of our 5 clusters, and it costs us a lot. Why? Because persistent volumes are awesome, but they are quite expensive, especially if you create thousands of them. So we came up with something else, with a different solution. It is called the self-contained solution because we put it everything. We used only Kubernetes API to create so huge number of container images. So manager creates a deployment, and deployment, of course, creates a pod. But in this pod, we have a couple of containers, and all of them, actually initialization container, the main container, all of them, they write to an empty volume. So we decided not to use persistent volumes. We decided to use an empty volume. But we also added 2 more containers. They were just sidecar containers. One of them is Docker in Docker container, which is used by a special container called builder. A builder just waits for this warming up phase to finish, and then it just grabs all the data that was written on the volume and creates additional layer with all the artifacts, all the specific data for this exam. And of course, after that, it just pushes the image into our private registry, but that's not all. Why is self-contained? Because after it finishes, it also deletes the whole deployment. The manager parts, what it needs to do is to check whether the container image is available on the repository. And that's it. So when a candidate joins the exam, we just launch a single deployment on the cluster, which is the closest to his or her location. So when it comes to managing multiple clusters, we have many things to consider, like infrastructure provisioning, managing manifest, security, and of course, how to deploy applications. Let me go through briefly through all of these topics. Of course, when it comes to cloud, it's 2022, guys. There's no point in talking like there's real alternative for Terraform. Terraform for the win, seriously. We use Terraform a lot to harness, to manage multiple cloud providers, because we use not only GCP, we use AWS as well, we use Azure, and even cloud. We also use Terraform to manage Cloudflare and HashiCorp Vault, which I will mention in a few slides. We wrote some custom modules, but we started also using official modules as well. So Terraform, obviously, and we added something that we missed in Terraform. So we wanted to check, we wanted to have some kind of pull request builds for Terraform. back then we didn't use Terraform Cloud. However, we decided to build our own kind of self-made solution. So we used Jenkins. We use Jenkins a lot. And in Jenkins, we have a specific job that runs whenever we create a pull request on our GitHub repository. And of course, this pull request job, its main job is to just perform Terraform plan, so some dry run. And of course, after the merge, another job gets executed when, and then all of the resources are created or synchronized with the code. So, is it perfect? Of course it's not. And in hindsight, I would say that probably I wouldn't use Jenkins' job for performing such tasks. I would probably use Terraform Cloud, which is pretty good these days, or Atlantis, which is an open source project, or which is, I'm not sure if you know, guys, but we have a very interesting Polish startup which is called Spacelift, and they also provide some services which help to automate, which helps us to use pull request features and so on. So yeah, so actually, I'm a huge fan of everything as code approach, and we have two set of tools that we use to implement this approach. One of which is, of course, Terraform. So we either write Terraform code, or we write some Kubernetes manifest. And by using these two tools, we manage to automate everything and keep everything as code in our repositories. So how we manage a Kubernetes manifest for the apps? We decided to use Customize instead of Helm chart, for example. But like I mentioned, conventions and standards are the key. So we use global configuration repository in which we keep templates. And these templates are used by all of the applications developed at DevSkiller. So every application get the best practices that we put in those templates. And we use, of course, CI/CD pipeline for deploying, and in these pipelines we use Scaffold, which is kind of a glue that glues all of the pieces together. And of course, the CI/CD pipeline is responsible for building, testing, and deploying our apps to all of the environments, including production, of course. But that's not all. So when it comes to applications, of course, we use CI/CD with Jenkins. However, we also use this modern approach called GitOps. We use this global configuration repository, and we use Argo CD controllers that are installed on every Kubernetes cluster, and these controllers just use the data from GitHub repositories. Actually, I don't think there is something better these days than Argo CD, and that's why, well, if you want to use, if you want to try with GitOps, just go ahead and install Argo CD. So one thing that we also missed in Argo CD was the feature. We wanted to have something similar as we had with Terraform, so we decided to write our own Jenkins job to make some kind of equivalent to Terraform plan. So we used a dedicated job to just display diffs of the code that is placed in this pull request, and it's different from the current state of the objects in our cluster. So that was it. But let me just go back to Jenkins. We use Jenkins a lot. I wouldn't say we overuse it, but we have almost all of the things that can be automated. They are automated using the tools that I described, or some Jenkins jobs. The key here, the key for robust and efficient Jenkins is to run it inside the Kubernetes. Seriously, just run it inside a container and configure it like we did. Configure it using code, using configuration as code, and by using that, our Jenkins is just boring because it just works. Whenever a problem happens, sometimes it's just a matter of recreating some dynamic node, because we use dynamic pods, which are created by Jenkins, or dynamic virtual machines. We found out that virtual machines are just faster. So if we, for example, we use end-to-end tests, and we found out that by using a dedicated virtual machine, it's just faster, and they are not as expensive as you might expect, because we just use them for like 10 hours per day. Whenever we start it in the morning and we just kill it, we just destroy it in the evening. Of course, it is done automatically by Jenkins. Of course, Jenkins manages or auto-discovers our repositories, because we use GitHub. We have our own dedicated GitHub organization. And of course, Jenkins, like you noticed before, is responsible for the deployment of our apps. But when it comes to Jenkins, we also found out that, once again, conventions and standards are the key, and this is actually a working solution. This is a free node Jenkins file, which is a valid file that would create a pretty complex Jenkins pipeline, which includes building, publishing, end-to-end tests, and all the deployment steps that are required. However, so we follow this very, very simple approach. However, when it comes to maintaining the code, we use, of course, shared library. However, it is not such nice inside, underneath. We struggled a bit with testing. Maybe it's because I'm really lousy Groovy developer. Yeah, it works. However, if you want to test something, we just launch a dedicated kind of end-to-end test. So once again, can you do it better? Of course you can. I would stick with customized for apps, but definitely I wouldn't write my own manifest for services such as RabbitMQ or anything that is not developed by me. I would just use official Helm charts. There are plenty of them. And one very, very important thing, I would get rid of the shared library. I wouldn't use Jenkins as a platform. I would use it only as an executor. That's it. Because maintaining this Groovy, maintaining logic inside Groovy is not the best idea. So, and this is the last part that I consider to be very popular sometime in the future, or maybe it is now. I would divide, I would decouple CI from CD, and I would use Jenkins or some other piece of software for continuous integration, and Argo CD for continuous deployment. That's the future, guys. So when it comes to security, I can tell you, about all the processes that we implemented at DevSkiller, but I would rather tell you something more important. Of course, we have this scanning feature enabled in our CI/CD pipelines, and I remember one situation when Trivy, because we use Trivy found some vulnerability in one of the artifacts, one of the libraries, I guess, in the main component of our application. And it turned out that the fix exists in some newer version of Spring Boot framework. And which meant that some guy had to just upgrade the whole framework, which was not easy, and it took him a few days. It required a lot of work, but there was no complaining. It had to be done. That's it. And it's not about some fancy feature that you put inside CI/CD. It's about culture. And this is something that I've learned. You can have secure applications if you have a team that feels this responsibility and has this ownership. Okay, when it comes to security, there is one one hot topic, I would say, how to manage secrets. So let me tell you about our approaches to the problem. Our first, very basic, this is something that was when I joined DevSkiller. We had a very simple symmetric key. We used Ansible a lot. And we use some symmetrical key to encrypt data in our Git repository. And then we had to manually apply our manifest. So as you may notice, it was before our GitOps approach. So the second solution was a lot better. So we used GCP Secret Manager to store also some symmetrical key, and after authentication, you could get your key to decrypt and to apply your manifest. So this was much better because we use group membership and to grant access to our encrypted data. However, it wasn't perfect, of course. So when we decided to move on with GitOps approach, we had to come up with something even better. And we used external secrets. So we decided that we didn't want to store any kind of encrypted data inside Git repository. We wanted to have some references to some real data that is stored somewhere else. And as you may expect, this somewhere else, this is a sample manifest for external secret object. And as you may expect, this something else is HashiCorp Vault. And external secrets just download all the data that is required for our apps, and then, which is very simple, it just transforms this data to some secrets. However, one thing that is worth to mention here, Vault is really, really awesome product and project. It's probably the best that you can have, especially if you have on-prem environment, if you don't use cloud. And Vault is even better if you decide to use dynamic secrets like we decided. So for example, if you provide access to your databases based on some dynamic logins and passwords instead of static ones. It works flawlessly, like seriously. However, one important thing when it comes to Vault, that it's a service. And this service needs love, and needs a lot of love in order to keep it secure, to keep it reliable, to keep it manageable, to keep it up to date, and so on. So if you consider using Vault, try to at least come up with some other scenarios than just simply putting static data, dynamic, and find some people that will be responsible for it, because it becomes a very crucial then, a very crucial service then. So that's how it looks like. Okay, but when it comes to security, I have one important rule when it comes to managing secrets. There is one. It's not about encryption method that you choose to use. It's not about any fancy object like sealed secrets, even external secrets. No, it's about making sure that you provided restriction to access to your cluster. So role-based access control is far more important than encrypting your secrets. Just remember that and start with securing access to your cluster first. Okay, so I owe you the final solution. Okay, I'm ready. Like I mentioned, it's a little bit embarrassing. We should have read documentation more thoroughly, because in the documentation, in Google documentation, there is a piece of information about cluster upgrades. And what it says is that cluster upgrade is a voluntary type operation, which means we can control it. We can control it. How? Pod disruption budget. Well, this is a very innocuous object. So it doesn't do actually anything besides just providing some information about your pod disruption, about your error budget. Okay? So this was our success, because these are 9 lines of manifest that we had to create in order to prevent our outages from happening. Let me just go through the scenario once again, but this time with pod disruption budget defined. So once again, upgrades gets initiated by Google. One appears, of course, the old one gets destroyed, another one appears, the old one gets destroyed. But this is when there's the biggest difference. Now, Google, which controls the cluster upgrade, waits for the apps to be available, because if it had decided to destroy the old node, it would exceed the budget that we set in our pod disruption object. So after the new apps are ready, then it can safely remove the old node. Of course, after some time, it can be like, I don't know, even 20 minutes, it doesn't matter. Finally, they will eventually start and they will be available. And with a little bit embarrassment, but we defeat our problem, I would say. Okay, so I'm grateful that you decided to stay with me. And I have some surprise for you. So if you want to break something on your own, I prepared 2 free ebooks. One of them on the left side is an ebook that will allow you to create your own cluster, 4-node cluster in the cloud. I won't reveal which cloud, but it's not a scam. A few hundred people have already downloaded it. I got no complaints, so it works. And the other one, you can download it if you're interested in some techniques of deployment to Kubernetes clusters. And if you want, you can follow me on the social media. And I guess that's it from me. Thanks.